This is a GMAT data sufficiency question. This is from coordinate geometry. I'll classify this question as a 700 level question. Let's get started. Line L is perpendicular to line K, whose equation is 3y equals 4x plus 12. This is the equation of line K. All that we know about line L at this point is that it is perpendicular to line K. Lines L and K intersect at a point P, Q. What we need to determine is whether the sum of P and Q is a positive number. It's an is question, been given two statements. As always, before looking at the statements, let's get clarity on what we need to find out. We need to determine whether the sum of these two values, P and Q. What are P and Q? P and Q are the x and y coordinates of the point of intersection of lines K and L. If that number ends up being a positive, our answer to this question is going to be yes. If P plus Q is greater than 0, we'll answer it with an S. Conversely, if we get P plus Q is less than 0 or is equal to 0, then we'll say the answer is no. We need to use the two statements to determine that. But before proceeding any further, let's get some understanding about what these lines are at the question stem level. The equation of line K is given to us, which is 3y equals 4x plus 12. Let's find out what this line is. Where does it cut the x-axis? Where does it cut the y-axis? What is its slope? Which all quadrants does it pass through? All that we need to do to get there is to basically compute the x and y intercept of this line. Let's start with the x-intercept, right? We'll compute the x-intercept of line K. We are looking at line K. Substitute y equals 0. If y is substituted as 0, because where it cuts the x-axis, wherever it cuts the x-axis, the y coordinate is going to be equal to 0. So if I substitute y as 0, 0 equals 4x plus 12. Solving for x, we'll get x is equal to minus 3. So it cuts the x-axis at minus 3, 0. That's the x-intercept of line K. Let's quickly run through the y-intercept. The place where it cuts the y-axis, the x-coordinate is going to be 0. So I'm going to plug in x as 0 in this equation. So we'll get 3y equals 12. If 3y equals 12, we get y is equal to 4. The place where it cuts the y-axis, x-coordinate is 0. So the y-intercept is 0, 4. So x-intercept is minus 3, 0. Y-intercept is 0, 4. This is the line we are talking about. This is x-intercept. This is a y-intercept. Equation of the line is given to us. Now look at it. This line passes through the first quadrant, the second quadrant, and it also passes through the third quadrant. And it's quite evident, if we rewrite it as in the y equals mx plus c format, the slope would have been a positive number. This definitely is a positive sloping line. Let's spend a minute on understanding what we need to find out. We need to find out whether P plus Q is positive. P and Q are the coordinates of intersection of this line K with line L. At the question stem level, all that we know is that line L is perpendicular to line K. Line K passes through these three quadrants. Line L is perpendicular to it. In one instance, it could intersect with it in the first quadrant. That's a possibility. This is line L. We haven't seen the statements yet. All that we know is that it is perpendicular. Line L could be this line. It could be parallel to the first line, intersecting with line K in the second quadrant. This could be a possible candidate for line L. The third possibility is that this could be our line L intersecting with it in the third quadrant. If from the statements we are able to determine that it intersects in the first quadrant, both P and Q are positive, the answer would be yes. So if this happens to be our line L, if we can determine that from the statements, then the answer is yes. If this happens to be this candidate, let's say 3 is our line L, then the point of intersection is in the third quadrant. In the third quadrant, x is negative, y is negative. The sum is going to be definitely negative, which means we have a conclusive no as an answer. This is where there is a trouble. If it intersects in the second quadrant, x is negative, y is positive. In that case, there could be values of x. Here, the negativity of the x is far more than the positive value of y. Net result is going to be negative. If I go closer to the y-intercept, the negative value of x is much lesser than the positive value of y, which means the net result could be positive. So the intersection is in the second quadrant, then we'll say the answer is maybe. So all that we need to do is basically from the statements, check out, can we determine which among the three possibilities is line L? And if it is this case, do we know where is it exactly intersecting to be able to determine whether it is positive or negative? Quickly summarize all of these things in a printed form before we look at statement 1. This is what we have. The x and y intercept of line K are minus 3, 0 and 0, 4. It's a positive sloping line. That's quite evident. Line L is perpendicular to line K. coordinates of intersection of these 2 points, of these 2 lines, is given by P comma Q. What we need to determine is P plus Q positive. If the point of intersection is in the first quadrant, as I had mentioned, P plus Q will be positive, the answer will be yes. The point of intersection is in the third quadrant, P plus Q will be negative, the answer will be a definite no. If the point of intersection is anywhere here, we need more inputs. If it's in the second quadrant, we need more inputs. Is this point or is it this point? We actually need as much as knowing the exact value to be able to determine whether P plus Q is positive. Let's start by evaluating statement 1 alone. It says that the x-intercept of line L is less than that of line K. Do we know the x-intercept of line K? Yes, we computed it a little while ago. That works out to minus 3, 0. Let's draw both these lines. Let's start with one premise. We're going to look at this as line L. This is not line L for us given this statement, but let's start with this. If line L had been this line, which had the same x-intercept as that of line K, the point of intersection is going to be at minus 3, 0 for both these lines. They both are having the same intercept, therefore they'll have to meet here. But this statement says that line L's x-intercept is less than the line and x-intercept of line K. Line K has a minus 3, 0 as the x-intercept. So this number, the x-intercept of line L, has to be lesser than minus 3, which means it has to be to the left of the x-intercept of line K, which means this is obviously not our line L. This is what our line L is. The moment the x-intercept of line L moves even a little left to minus 3, the point of intersection slips into the third quadrant. If the point of intersection is in the third quadrant, we know that both the x and y coordinates are going to be negative. If both the x and y coordinates are negative for the point of intersection, the sum of P and Q will definitely be a negative number. So you can come up with a conclusive no as the answer to this question. It's quite evident that the 2 lines will intersect in the third quadrant. In the third quadrant, any point will have its x and y coordinates as negative, which means P plus Q is not greater than 0. We have got a definite no as the answer. So statement 1 alone is sufficient. 1 alone is sufficient. We can rule out answer options B, C, E. We are down to just A or D. To determine whether it is A or D, let's evaluate statement 2 alone. This statement talks about the y-intercept. Y-intercept of line L is less than that of K. What is the y-intercept of line K? We found that to be equal to 0, 4. Let's quickly run through how it is. This is the y-intercept of line K. The statement mentions that the y-intercept of line L is lesser than that. If this is 4, it can be anything less than 4. It can be a 3, it can be a 2, it can be a 0, it can be a minus 5. It could be anywhere here. Any of these things would be potential candidates for our line L. Now I'm going to approach it as a counterexample. Let me see if I can get 2 possible values. One case where P plus Q is positive and another case where P plus Q is negative. If I can come up with something like that, then we'll say with this information, I'm not able to determine whether P plus Q is positive. I'm looking at this scenario where it's intersecting in the second quadrant. Let's look at some point where it's intersecting this point. I'm going to pick such a value for this point where the net result is going to be positive, which means that it should be closer to the y-axis than to the x-axis. Let's look at a point which will satisfy this equation. The equation of this line is equal to 3y is equal to 4x plus 12. Let's pick a point, say something like minus 1.5, 2. Minus 1.5, 2 will satisfy this equation, right? Which is essentially 3 times 2, which is equal to 6. 4 into minus 1.5, which is a minus 6 plus 12, which is also equal to 6. So minus 1.5, 2 is a point on this line. Obviously, if it's a point of intersection, it should be a point on this line. So this definitely is a potential candidate for the point where line L and line K can intersect. If that be the case, what will be the value of P plus Q? Minus 1.5 plus 2 is a plus 0.5. P plus Q is positive. I found with example 1 where it is intersecting in the second quadrant, and I picked such a point where P plus Q is going to be positive. To pick a point which is negative, let's not even look at second quadrant. Let's just quickly jump to the third quadrant, because the y-intercept of line L should be lesser than the y-intercept of line K. It can go all the way down to minus infinity if we choose to. So if it is a value which is negative, then obviously we realize that the point of intersection moves to the third quadrant. Let's pick any point in the third quadrant. We know that both P and Q are going to be negative, which means the sum P plus Q is negative. With the example where it intersected here, we got P plus Q to be equal to here, P plus Q is less than 0 in this example. In the example 1 where it was intersecting somewhere here, we got P plus Q to be equal to positive. Here we know P plus Q is negative. So we got a counterexample. If a counterexample exists, we are not able to come up with a conclusive answer. So statement 2 alone is not sufficient. 1 was sufficient, 2 is not sufficient. Answer option A is the correct answer to this question. Before you leave, I want you to do 2 things. Sign up as a trial user at wzko.in/core. Right? It's a very comprehensive quant course starting from absolute basics and walking you through questions which will take you to Q50 plus level in the GMAT quant. And also subscribe to this channel if you have already not done, youtube.com/Vizaco, and turn on notifications to get notified about any new videos or community posts that we'll make. Best wishes for your GMAT preparation.